Hello, Algebra 2 folks, and today we're going to start solving by factoring. So today we're going to start the parts of the quadratic formula where we have 4 different ways that we can solve a quadratic. And so the first method is solve by factoring. So you're going to need your notes. You're probably going to need your flip chart available for factoring just in case you need to have that handy to know how to factor. All right, so before we get started here, I want to talk about some prior knowledge. So you're going to need to know those 4 ways of factoring that we have talked about in the last 2 days at school. Remember on the last day that we had class, we talked about the greatest common factor and that sometimes you need to take out the greatest common factor first, and that will help you get started. And so there will be times when you have to factor more than one time. Remember, always start with the greatest common factor. Then decide what method you're going to use based on what your expressions look like. How many terms do you have? Do you have 4 terms? Then you use grouping. If you have 3, then you use the AC method. If you have 2 and you have a difference with some squares, then you use the difference of 2 squares. You already know how to factor, or you should already know how to factor, but how do we use it to solve? Okay, so AKA, we're finding X. All right, so if we are trying to find X, then what does that mean? That means that we have an equation. When we factored the last 2 days, we had expressions. We didn't have equations. Now that we have an equation, we have to find X. All right, so first and foremost, we're always going to make sure that we are set equal to 0. If you don't have it set equal to 0, then get everything on one side and have it set equal to 0. Then we're going to factor. And remember, we're always going to say, is there any greatest common factoring? So if I take x squared plus 9x plus 14, do they have anything in common? No. So we're not going to greatest common factor. Then we're going to look at it and say, oh, we've got 3 terms. I'm probably going to use the AC method. All right, so A is 1, C is 14. So 1 times 14 equals 14. 2 factors of 14, that adds up to be 9. Yep, that would be 2 and 7. Go ahead and replace that middle term. So bring down the first term. Bring the 2x and the 7x over. That replaces the 9x. All right, and then bring down the 14. Okay, so now we can do 4 squares here. And put the terms inside the squares. And then we can factor the first row. That has an x in common. The second row has a 7 common. The first row has an x in common, and the second row has a 2 in common. And so the 2 factors are x plus 2 and x plus 7. Then we bring the equal 7 down, and now we do the next step, which says set each factor equal to 0. And so I am going to take my x plus 2 and set it equal to 0 and solve. So x equals negative 2. And then I'm going to take my x plus 7, because this is a factor and this is a factor, and I'm going to take x plus 7 and set it equal to 0, subtract 7 from both sides, and x will equal negative 7. Now notice I have an x and another x, and so my solutions here are 2 x values, negative 2 and negative 7, which means they cross the x-axis at negative 2, 0 and negative 7, 0. So you can either write it as 2 x-intercepts, or you can write it as negative 2, negative 7 with these squiggly lines. But you cannot write negative 2, negative 7 in parentheses. This is not an ordered pair. Okay, so it is really important how you write your solutions, and I have been trying to talk about that for the last 9 weeks. So we have to know what we're talking about, and we're talking about 2x values. All right. So either ordered pairs, 2 separate ordered pairs because they're on the x-axis, or the solution would look like squiggly lines, -2, -7. All right. Why are we setting each factor equal to 0? Well, let me just take a second and pretend for a minute. This is really easy. I am thinking of 2 numbers. They multiply to make 0, but my first number is 7. What's my second number? Oh yeah, this is not rocket science, people. 7 times 0 is 0. So the second number would have to be 0. So in order for us to do this, set each factor equal to 0, that's kind of what we're doing. And it's called in Algebra 2, which you need to write this down, it's called the zero product property rule. It says when 2 things multiply to make 0, one or both of them has to be 0. So because my factors are set equal to 0, I want to find out what each factor equals 0 so that I can get the other side to be 0. All right, so that's why we can do it. So let's do another example. All right, so it says factor and solve. Well, I always want to make sure it's equal to 0 so we can use that zero product property rule. That's why we have to have it set equal to 0. Now we're going to take this 4x squared plus 22x plus 10, and we're going to factor it. And this is where we always have to ask ourselves, is there anything in common? Greatest common factor. All right, well, I see a 2 in each one of these, so I'm going to take a 2 out. Okay, and now that I take a 2 out, I can look at my new 3-term problem and say, what kind of factoring am I going to use? Well, it's 3 terms, so I'm going to use the AC method. So I'm going to take my A, which is 2, and my C, which is 5, and take 2 times 5 and get 10. And then I'm going to find 2 factors of 10 that make 11. Yep, here is where this one's hard for us, and I don't know why, but remember 2 factors of 10 that make 11. Don't forget the 1 and the 10. The far factors sometimes do work. So 1 and 10 make 11. So I'm going to rewrite the problem. 2x squared, I'm going to get rid of that middle term. That's always our goal. Rewrite our new 2x's in there. Bring down this 5. Don't bring down that 10. And don't bring the 10 over here. You always bring down this c, right above it. And then do your 4 squares. So 2x squared, 1x, 10x, 5. Top, have an x in common. Bottom row has a 5 in common. First column, 2x. Second column, a 1. And so our factors are 2x plus 1 and x plus 5. And we can set them equal to 0 because we're going to use the zero product property rule. And we're going to take each factor, this factor, and set it equal to 0. Subtract 1. 2x equals -1. X equals -1/2. Then we're going to take this factor and set it equal to 0. Subtract 5 from both sides, and x equals -5. Now, we can either, like I said, you can either say -1/2, squiggly line, -5. Those are my solutions. Or my solutions are 2x values that if I graph them on a coordinate plane, it would be -1/2, 0, and -5, 0. All right, so those are the solutions of that equation. Now let's do another example. This equation says 9x minus 8x equals x squared. Oh, silly. Why would I write 9x minus 8x? That's just an x. So I'm just going to write 1x equals x squared. Okay, now I want to get this so that it's set equal to 0. But here's what I'm going to tell you. Always keep your x squared positive. Anytime we factored greatest common factoring, well, not so much greatest common factoring, but grouping, AC, difference of two squares, that x squared was always positive, and it is so much easier to factor when x squared is positive. So instead of subtracting the x squared on both sides, I'm going to subtract the 1x on both sides. So it's going to look like this. It's going to look 0 equals x squared minus 1x. Now, does it matter if my equals is over here or if my equals is on the right-hand side? That's a no. It doesn't matter which side the 0 is equal to. So now I can go ahead and factor it, and I'm always going to ask myself, do they have anything in common? Well, yes, they do. They have an x in common. So I'm going to take out an x. And when I divide out an x, I get x minus 1. Now, can I factor it any further? And I would say no, because I have an x to the power of 1, and I have an x to the power of 1. And we've been factoring x to the power of 2's. So I can't factor an x to the power of 1. So these are my two factors. So I am going to take my x and set it equal to 0. And I'm going to take my x minus 1 and set it equal to 0. And x is going to be 0, and x minus 1 is going to be 1. Now my solutions here are going to be 0 and 1, or 0, 0, and 0, 1. Now, I want to take you back to the last problem here really quick and show you something. This is why audio is really important. I didn't say this or do this in the last problem because it throws everybody off. And so if I do example 3 first, sometimes example 2 would make a little bit more sense. But remember this greatest common factor that we took out? Now remember, we should have brought it down here. Now the reason why I didn't is because it's a 2. And does 2 equal 0? I would hope you're going to tell me no. So is that going to give me a factor? No. I have an x squared here. So how many solutions do you think I should get at the end? Right, I should get 2. Because if I have x to the first, I get 1 solution. If I have x to the second, I get 2 solutions. This does not have an x. So if it doesn't have an x, no x means no solution. This is not going to give me a solution, but these two are. Now if I move it to the next slide, my greatest common factor that I took out was an x. So this will give me a solution. Okay, so when I set that equal to 0, it does equal 0. So I didn't put that 2 out in front, even though we should have, because it always confuses you. So now hopefully that makes a little bit more sense that that is not going to give us a solution. Yes, it helps us get the factors, but it doesn't help us with a solution unless it has an x. All right, folks, that's it. Enjoy the rest of your evening. We'll see you tomorrow.